In this video, we are going to discuss some problems based on division algorithm. So before we start with the problems on division algorithm, let us recall what is the division algorithm. So if I'm given b to be an integer and a is a non-zero integer, let's take a positive. Then, and if I divide b by a, then we are going to get a quotient and a remainder. So there exists quotient q, which is an integer, a remainder r, which is also an integer, such that dividend is equal to divisor into quotient plus remainder. That is b is equal to aq plus r, where the remainder lies between 0 and less than a. So this is the statement of division algorithm, where a I have taken a positive non-zero integer. Now, using this division algorithm, we can actually prove that every integer is either even integer or it is an odd integer. So we all know what is meant by an even integer. So even integer is a number which is 2 into something, which is 2 into some integers, where k is an integer. And what is an odd integer? Odd integer is something which is n, that number can be represented in the fashion n equal to 2k plus 1, where k is again some integer. So any number which is of 2 times something will be an even number. Any number which is 2 times something plus 1 will be representing an odd integer. Okay, so let's take a question. Say, show that any integer n is either of the type 2k or 2k plus 1. Means every integer is either even or it is odd. Okay, so this is a very simple application of division algorithm. So we will take integer n. So let n be any integer, and I'm going to take the value of a equal to 2 and apply division algorithm. And apply division algorithm means I'm going to divide this n by the number 2. Okay, so by division algorithm there exists a quotient and there exists a remainder r, such that dividend means n is equal to divisor, which is 2 into quotient q plus remainder is r. So this is the dividend, this is the divisor, this is the quotient, and this is the remainder. And we know something about remainder. The remainder should always be less than the divisor. So the remainder here is less than 2. This is the divisor. Remainder should be less than the divisor, and it is greater than or equal to 0. And remember that remainder is an integer. Right. So what are the integers which are satisfying this property? So what is the value of r which is less than 2 and greater than 0? So clearly remainder can be 1, because 1 is less than 2 and greater than 0. And you can have 0 is less than or equal to, so you can even take 0 also. So the only two choices of remainder are what? 0 and 1. So if you now write what is n equal to from above, n is equal to 2q plus r, where r is having only two choices. R is either 0 or 1. So if I make two parts, If I put r equal to 0 and if I put r equal to 1. If I put r equal to 0, then n is equal to 2q plus 0. If I put r equal to 1, n is equal to 2q plus 1. I'm substituting the value of r in this equation, n equal to 2q plus r. So this means n is equal to 2q or n is equal to 2q plus 1, where q is some integer. So we have eventually proved that any integer n is either in the fashion 2 times something, 2 times q, or 2 times q plus 1. This is what we wanted to prove, and therefore we have proved that any integer is either even or odd. Okay, now let us see one more simple application of division algorithm. So now we know what is even number. Even number is 2 times something, and odd number is 2 times something plus 1, means 2q or 2q plus 1. This is even and odd. Now if you take any odd number in your mind, so let me write it as a question. So let n be odd. So n is an odd integer. Then we can show that n square minus 1, if I calculate n square minus 1, then it is a multiple of 4. Is a multiple of 4. So let me just do some rough work here. So if I suppose I take a number in my mind as say n is 5, and if I find n squared minus 1, it will be 25 minus 1, which is 24, which is a multiple of 4. So if you do this for any odd number, and if you take the square of that number and if you subtract 1 from that number, then you will understand that n squared minus 1 will be always a multiple of 4. In fact, we will go much ahead of this and we will try to prove that it is not only a multiple of 4, but it is a multiple of 8 also. That will be some next exercise. So let's try to do this elementary part first. So let me write the solution. So we know that n is odd, so let n be odd. So this means n will be of which type? N will be of the fashion 2k plus 1, correct? And therefore I will calculate k is an integer, and then I will find n square. So n square is 2k plus 1 the whole square, which is 4 into k square plus 4 into k plus 1. Okay, this is n square equal to this. Therefore, what is n square minus 1? This plus 1, I'm going to shift on that side. Okay, so n square minus 1 will just be 4k square plus 4k. And therefore, I'm getting that n square minus 1 is actually 4 times k plus 1. I'm taking 4k common. So this means that n square minus 1 is equal to 4 times some k dash. What is k dash? The value of k dash is k into k plus 1. So this is also an integer. So I proved that n square minus 1 is 4 times something, where this something is integer, which means that n square minus 1 is nothing but 4 into something, means it is a multiple of 4. Therefore n square minus 1 is a multiple of 4. Okay, now remember this expression. This expression will be very useful for us in the next problem. Okay, that n square minus 1 is 4 into k plus 1, where k is an integer, where k is always an integer. So let me make a note here. So note, if n is integer, if n is odd integer, sorry, then n square minus 1 is 4 into k plus 1, where k is an integer. So this important result we are going to use later on. Okay, now if you see any two consecutive numbers, now pick up any two consecutive numbers. What are consecutive numbers? For example, 6 and 7, okay, 8 and 9, they one after the other. So if one number is n, the other number is n plus 1, right? So these are the consecutive numbers. Now if I take the multiplication of any two consecutive numbers, you see here the multiplication of two consecutive numbers is 42, here the product of these two consecutive numbers is 72, and so on. So what I'm trying to guess is that if I take any two consecutive numbers, the multiplication of those two numbers must always be what? It must be always even. Okay, so this is a very simple exercise, that product of any two consecutive numbers is always even, which is a very obvious observation. So product of any two consecutive numbers is even. Okay, so let's try to quickly justify it. Now we know that if n is an integer, then n plus 1 is also some integer. Now this n has two choices. N has two choices. What are the two choices of n? N is either even or n is odd. Okay. If n is even, now let's take what is n plus 1. In that case, here n is even means what will be n plus 1? N plus 1 will become 2k plus 1. And here if n is odd, then n plus 1 will become what? 2k plus 1 plus 1, right? So I'm taking n plus 1. So this is 2k plus 1 plus 1. So it means n is 2k. In this left hand case, let's solve the left hand case now. N is 2k, and what is n plus 1? N plus 1 is 2k plus 1. Okay. So if I'm looking only at the left, now let us pay attention at the left hand side. So value of n is 2k, value of n plus 1 is 2k plus 1. So what is the product? What is the multiplication of the two numbers? It is equal to 2k into 2k plus 1. So do you see it is multiple of 2? So it is 2 into something. It is 2 into k dash. What is the value of k dash here? Here k dash is k into 2k plus 1, which is an integer. So I'm getting that in the first case, in the left hand side case, I'm getting that n into n plus 1 is 2 times something. Means what can I say about n into n plus 1? It is 2 into something, right? So it means that n into n plus 1 is even. Right. Now let us look at the second part. Now in the second part, n is 2k plus 1 and n plus 1 is 2k plus 1 plus 1. It means that n is 2k plus 1. And what is n plus 1? N plus 1 value is 2k plus 2, because this 1 plus 1 is 2. So if I multiply them, n into n plus 1, what is the multiplication of n into n plus 1? It is 2k plus 1 into 2k plus 2. Can I pull out a 2 common from this bracket? Yes. So if I put 2 common, I'm going to get 2k plus 1. First bracket will be as it is. And second bracket will become what? K plus 1, because I'm pulling out 2 common from the second bracket. So this is also looking like 2 into k dash. What is the value of k dash over here? K dash is 2k plus 1 into k plus 1. So this means that in the second case also, n into n plus 1, when I calculate, when I simplified this n into n plus 1, it comes up to be how much? It comes up to be 2k dash. Means n into n plus 1 is again which type of number? It is even. So in both the cases, we reach that n into n plus 1 is even, and therefore we can conclude that product of any two consecutive numbers is always even, right? And therefore, by the above observation, we have written here a very important box thing, that n squared minus 1 is 4 into k plus 1, right? So by above note, so what is our note? So by note, what is our assumption? If n is odd, then n squared minus 1 is 4 into k plus 1, where k is integer, right? And therefore, this k into k plus 1 is product of two consecutive integers, right? So this has to be what? This has to be even, because it is product of two consecutive numbers, and we have proved that the product of two consecutive numbers is always even. So this means that n squared minus 1 is 4 into some 2k dash, right? Because it is even. Any even number is of the form 2 times k dash, where k dash is an integer. And therefore, eventually we are getting that n squared minus 1 is 8 times k dash. K dash is a integer. So what have we proved? What is the conclusion of our discussion here? So the conclusion is that if n is odd, and if I calculate n squared minus 1, it is what? It is always divisible by, it is a multiple of 8, right? Means it is divisible by which number? It is divisible by 8, right? If you take any number, suppose I take 7, and if I take the 7, the square of the 7 and subtract 1 from it, is it a multiple of 8? Yes, because 7 square is 49 minus 1 is 48, and which is a 8 in which is a multiple of 8. So it is 8 into something. Let me try one more integer. Suppose I take 9. What is 9 square minus 1? 9 is also odd. Okay, we need odd integers. Don't take even integers. See, n is what type of number? N is odd. So what is 9 square minus 1? It is 81 minus 1, which is 80. And 80 is also a multiple of 8, right? So this result is verified. We have verified by two small examples also. And we have even proved it above, that if we take any odd number, and if you take the square of that number and subtract 1 from that number, you will always get a number which is what? Which is divisible by 8. In the next video, we will see some more problems on division algorithm.